So my name's Melissa Broadway and I am currently the EAZA Animal Welfare Coordinator. So welcome again. Without further ado of the housekeeping and nitty-gritty, let me introduce Isabella, because we're just so thankful to have her joining us today to talk about such an interesting topic of cognitive bias. So Dr. Isabella Clegg is an animal welfare scientist, and she also specialises in marine animal welfare in captivity. She has a number of degrees in animal welfare and behaviour and marine mammal science, and her PhD focused on developing welfare parameters for bottlenose dolphins in captivity. She's also the founder of Animal Welfare Expertise, which is an animal welfare consultancy that established the Sea Well assessment for dolphins, but also advises at different animal facilities, government bodies, NGOs, travel companies, and conservation projects on animal welfare. She also has given a TED talk recently about how studying animal welfare can teach us about our own happiness, which was really interesting, and I recommend that as a watch as well. But just all in all, we're so thankful to have Isabella join us here today. I'm very much looking forward to the presentation, and on behalf of everyone, thank you so much for sharing your time and expertise. So without any further ado, I'm going to hand over to Isabella, and she can begin her presentation. So thank you, Isabella.
Thanks so much, Melissa. It's really, really kind. Let me just share my screen.
Perfect.
Working. That's all good?
Yep, that's working for us.
Brilliant. Okay. Yeah, thank you so much for that introduction. And as much as you're happy to have me here, I'm so happy to be here too, because I'm so happy to get a chance to still deliver this this talk to you guys, because I was really excited about doing it and about the rest of the whole welfare forum. So I think it's really great that these webinars are going on. So yeah, as Melissa said, this is the title of my talk, and in a little bit more I guess more easy to understand speak is are zoo animals optimists or pessimists, and basically why would we want to know, and how can we tell, how do we measure that? So that's interesting. Sorry. So as Melissa said, yeah, I'm going to talk in two parts for my presentation, and that's a little bit because I was going to give a plenary on cognitive bias as well as a workshop. So the first part is really much more of the theory. I'm definitely going to go back and look at some of the animal welfare assessment stuff in the zoo, how cognitive bias fits in with that, and also look at dolphin cognitive bias. That was my area of expertise with that, but it's quite a good sort of showcase for how this can be applied. Then we'll have a few questions, and followed by the more workshop practical side of it. So I really was trying to think of ways to, not that I can get everyone involved and asking questions as we're going along, but trying to get everyone thinking about how they'd apply it in their own settings, with their own animals, or you know, if you're a student and want to study it, what you might look for in a zoo to go and study. So that's the plan. No, that's not working. And then we'll end with more questions. So yeah, starting with welfare science, I know that I'm going to repeat a little bit of what Sally said last, or whenever it was, a month ago, but I feel like it's really important to get the sort of baseline covered, because this is a big part of the reason why cognitive bias is so useful. So welfare science, as we know, is spreading from farm animals to lab and companion and now zoo animals, which is great. The aim is to objectively measure the holistic concept of welfare. And there's been a lot of progress recently, not least that we can now assess positive as well as negative states. And even more so, we realize how important it is to look for the presence of positive, not just the absence of negative. We can now see that that's key to ensuring good welfare. And as Sally was talking about, we've got animal-based measures, which are things, output measures, so the animal's behavior, body condition, things that you can measure about the animal. These ones are the more accurate but more time-intensive ones. And you've got the other type of measure, which is resource-based measures, for example, the pool size or the enclosure size, which are more practical but are often less relevant to the actual individual animal. So what happens in assessments is that usually you take a mix of the two to try and get some of the more accurate ones, but also keep it practical. So the definition of welfare has always caused maybe some problems in the past. As Sally covered really well, it's now actually moved on to, we thought in the past it was maybe only based on health. For example, only animals in the best health would have good welfare. Then it was a sort of natural behavior argument where, okay, only animals that are behaving completely naturally can be in good welfare. Or there was this feelings-based camp where it was only the animals in good welfare if they feel good. Now, although it may sound the most subjective, and it is, this feelings-based definition is the one that's now most commonly used and is integrated in the 5 domains of welfare and really all of the sort of modern thinking on it, I'd say. And that's not to say that the others aren't, of course, health and natural behavior are included in that. It's just that, for example, with health, the welfare is only impacted if the emotional side of the health problem is there. So if the animal's feeling sick, then the health problem is indeed a welfare issue. So we're really just focusing on how the animals feel. And there's a few words that are always thrown around with that. For example, affective states, emotions. And this is a sort of diagram that helps me a bit and links to the definition I use, where you can think of, and this really applies to humans as well, I think, with having a positive emotions or affective states, with emotions being shorter term, and many of them make up a longer term affective state. You can also have negative emotions, which make up longer term negative affective states. And it's on this balance. And I think as people responsible for animals in captivity at least, but probably in the wild too maybe, but we always want this tilt of the balance to be towards the positive, sorry. That doesn't mean to say that we're going to eliminate all negative. That wouldn't be right. It wouldn't be helpful either. Some experiences are only good because of they can be compared to negative states. So just to say that we're always looking to keep that balance tilted towards the positive. So welfare assessments, I wanted to have this as a sort of separate section because, again, this is another sort of area of animal welfare science. So you can study an animal in a lab and see how it's doing, but really if you want to, I guess, understand more and in a more practical way about how it's doing in the context of a wider environment, facilities that have animals tend to try and apply welfare assessments, which are a set of welfare measures. And as I said, these can be applied to individuals, but also to groups at a time, to whole facilities at a time, and even across industries. And this is really where I want to reiterate something that Sally said, which was super useful to think about. As she was saying, individuals down to the industry level, this goes from the most accurate to that individual as a welfare assessment, down to the least accurate per individual, but the least time intensive. So you can imagine an assessment on one individual, and if you did that for all individuals in a zoo or something, that would take a lot of time. But industry standards like laws and regulations, they are generally apply to the whole sort of, you have industry standards of what everyone needs to achieve. And that doesn't mean that they are less, that they're less accurate. Conducting these individual assessments, and it's not that they're not linked either, conducting the individual assessments, that's what allows us to compare between these groups and facilities. So it's a sort of bottom-up structure as well, which gives us those industry standards. So it's really important that we see, I guess, also the progression. It's not that you have to use one or the other. They're all linked in together, but it's important, I think, to know the sort of different levels we're playing with. So zoo animal welfare, It's tended, this is a great graph from Sam Ward and her colleagues recently, tended to focus on mammals and charismatic megafauna, but it is increasing exponentially in zoos, which is really great. And as I said, these findings are informing best practice and audit frameworks and industry standards. And this is looking at that pyramid again and seeing what kind of assessments are out there already. So at the individual level, for example, you've got the University of Nottingham and Newcastle, who are developing an individual elephant welfare assessment. So is the EAZA in America. As Melissa mentioned at the beginning, the Seawell assessment is something me and my colleagues developed for dolphins. And then if you go up to the group level, you've got a few examples where this is put the logo of the welfare quality, which is a really, really great farm animal welfare assessment, which has been applied to 3, but I'm sure probably a few more zoo animals, but at the group level. And facility-wide, you've got zoos and universities teaming up, like Marwell and the University of Surrey, ZSL, Zoos Victoria, as Sally was talking about a lot last week, of course, where you can apply a welfare assessment, and as she called it, a risk assessment to the whole zoo to really find out which areas you want to focus your resources on. And then we've got industry standards too, which, for example, like EAZA, and there's lots of examples of these. EAZA, of course, the ZAA. I also put in there, as I was mentioning before, audit frameworks, which I think are really interesting, another element of welfare assessment. So you've got ABTERN, for example, STA Travel. So these are the people representing these travel companies that sell, tickets to zoos or a ride with an elephant. And now there's a lot more interest in these, big travel companies having welfare guidelines in place. And some are doing it more scientifically based than others, but there's a big movement towards it. And I think obviously there's a lot in common with what we do. And the EAM too for aquatic mammals. And like I was saying, these individual assessments, and especially, for example, this elephant one in the UK was influencing the EAZA standards. The Seawell was influencing the EAAM standards. So you can see how, individual bits of research can really make a difference. So I'd like to talk more about the Seawell assessment. One, because it's sort of my area of expertise and I helped develop it, but also because it's a really good example of why welfare assessments are great, and at the individual level they can give you loads of information, but probably for some of you watching they might not be practical. You might not have time or the resources to apply this to all animals in your facility. And so that's linking to what I want to talk to you about with cognitive bias. But the Seawell was, for bottlenose dolphins, we developed it in 2013. And as I said about that balance between animal-based and resource-based measures, we definitely had that here. We had about 60% animal-based, which was great. And it was covering all aspects of an individual's life. This was the sort of method that we went through to develop it. A big literature review, expert roundtables, in situ testing, so testing it on 3 facilities of bottlenose dolphins, and using those exceptional contexts. So those are situations where, for example, an animal was sick, or there was a social hierarchy disruption, and then applying the Seawell assessment to really see which of those measures sort of popped up at the time where that animal was experienced probably reduced welfare. Practically, it can be conducted on 10 dolphins in 2 days, and its bottom-up structure really helps application and scoring. So you can either apply the full assessment, or you can apply just part of it, and I'll explain that better on the next page. So this is the framework where, as I said, the bottom-up structure, you have these 36 species-specific measures which feed into the 11 welfare criteria. And these criteria and principles are actually applicable to all animals and have come from the welfare quality farm animal assessment that I adapted it from. They're slightly, so the wording slightly different, but they really are the same. And this is the point that, this can be applied to really all zoo animals. I think, again, Sally was talking about same kind of thing last week. And yeah, as I said, you can, for example, if you only wanted to look at, I don't know, health measures, you could only apply that health section of the assessment. So it's, yeah, making some parts of it easier. You know, it might take less than 2 days for 10 dolphins, but if you want to do the full thing, that's how long it would take. And here are a few examples of the measures. So we've got, for example, body condition scoring. This is the rate mark analysis. And this was a squinting scale that we put in there. So these are all the examples of animal-based measures, but there's also resource-based measures in there. And the application of the CWEL. So what is happening with that practically at the moment? That's basically what I'm doing at the moment, is applying it at facilities around the world, which we've done it so far in 8 facilities, which is coming up to 80 animals. We've adapted it for other species in bottlenose, so or at least Atlantic bottlenose. We've gone for Indo-Pacific as well as belugas. And really interestingly, and I didn't expect this, is that I'm working also with sanctuary projects and, you know, really different applications, not just the standard, you know, same type of dolphinarium or anything. Yeah, sanctuary projects who classically sort of don't believe in the methods of what the, you know, what was developed in dolphinariums or captive environments. Prospective assessment, so trying to do a theoretical welfare assessment to understand whether it would even be a good idea to move animals from one place to another. And we're now doing repeat assessments in varied contexts, so before and after transports, after acclimatization periods, moving to different environments, which again, like I said, about the exceptional context, that also gives us, every time, you know, we do it, we get more information about whether it's accurate and what needs to be changed, which yeah, leads on to the last point about it being definitely a working document where I'm updating it, you know, as new research comes in or as new practical experience that I gain comes in. And yeah, at that point, the other bit is that I'm starting to work with places that have made changes using the results of the CWEL, and then doing a repeat assessment and tracking that the welfare is actually increasing. So it still takes a long time, and, you know, 8 facilities, there could definitely be more, but I think it's a slow process, but you're learning a lot. So as I said, I wanted to ask this question, showcasing using the CWEL assessment. That does take a long time, and, you know, you can do the actual assessment on 10 dolphins in 2 days, but as an outside consultant, when I go into a zoo or a dolphinarium, it also takes time for me to learn the animals and to learn the setup of the place and to, you know, analyze the results afterwards. So one of the big questions I wanted to ask is there any way to make individual welfare assessments less time intensive? Now, I'm not going to give you it's definitely not an easy answer. Yes, kind of. I want to propose, and you can probably guess, cognitive bias as an alternative, and I'll show you why. But first, a quick slide on technology, because only sort of recently has this really hit home about how much this also can reduce the time needed to conduct welfare assessments. And basically it's because, yeah, collecting, entering and analysing all this data is what makes it so time intensive. So if there's a way that we can reduce that, then that's going to be huge. And there are definitely things. So there's things like accelerometers where you can put it on animals. Again, you need training, but put it on animals to track their activity and social behaviour and all this stuff. Remote cameras definitely are making it easier. But a really big one, I think, are these record-based sort of integrative platforms, which are helping with entering and handling all your sort of welfare data. And I want to showcase this, and this is why I've become so aware of it, is I'm working with animal care software to develop their welfare templates. And if you can see here on the video, you can put in, you know, your weight data, your enrichment, all of these welfare measures, which I've helped develop. And using their platform, you can just, if you've collected all that data for an animal over the past year, you can just click on, for example, like there, enrichment and visitor presence, and see whether the enrichment engagement has decreased or increased if there's loads of visitors there. You know, starting to answer these really big, interesting questions with literally a click. And I'm definitely not saying it's as easy as that. There's still work in collecting that data and entering it, but at least the actual analysis and asking the questions is made so much more easy, and it's so interesting as well. And I think, and keepers already are, you know, using these kind of platforms, but a number of them, not just animal care software, a number of them are starting to have welfare templates or welfare sections where they'll offer an assessment-like function for them. So I think that's something that I wanted to just mention to keep an eye on. And yeah, basically all because regular monitoring is key to enhancing welfare. So yeah, I think a quick word on technology, but back to the original question of can we make welfare assessments less time intensive? I want to talk about whole animal measures. So again, welfare is this holistic concept where you, as I've said, you need all these multidisciplinary measures, and usually using one unidisciplinary measure, which just means, for example, physiological, like, I don't know, cortisol, or one behavior, that's not going to be accurate for welfare. And then you've got this other really quite relatively recently developed group of measures, which are all encompassing multidimensional but single parameters, so they can be sort of tested just a single test, not the whole assessment, but they're still giving you measures of overall welfare. And there's several of these. One of them, for example, is human intuitive estimates. So that's looking at keepers or people that know the animals really well and asking them a series of standardized questions and getting their basically opinions on the welfare of the animal, which sounds again subjective, but it's shown. The University of Edinburgh and Edinburgh Zoo are doing some really great work on that, and they've shown that that's a really good measure of welfare. Qualitative behavioural assessment, that's also kind of similar with, you can have either experienced keepers or they've actually shown with some farm animals you don't have to be experienced in the species to qualitatively, so choose, get a list of, for example, the different aspects of a behaviour of an animal and its attitude. So is it excited, is it playful, is it sleepy, or lots and lots of different terms, and you pick out the ones that you think it's doing. And again, they've shown that this is a really good, they've matched it to objective behavioural indicators, and it does match. Neuroimaging, so again, this is one, you know, a single measure that you can do ECGs on the brains of animals and find out really basically what their affective state is, how they're feeling. This is a pretty new area of science where we're not quite sure yet exactly how to do it. It's also obviously really difficult with definitely zoo animals, but you know, any animal really, to keep them still and to understand it. So the last one on that list is cognitive bias, and in a recent review this was labelled as the most promising. So again, this is a whole animal measure. You can do this, you can test this on animals, and you'll get an answer of overall welfare. So what does cognitive bias mean? This is when cognitive processes are impacted by emotional state. And this is something that we have as well, definitely. Again. So we have it with the half full and half empty the glass paradigm, where some of us see it as half full, some of us see it as half empty. And the idea is, this is more with animals really, but that a good environment where, for example, you have shelter, food, water, stimulating environment and friends, you are going to be more optimistic, you're going to take more risks and expect better outcomes because that's what you're used to. And in a poor environment, on the inverse, then you're going to judge more pessimistically. And the really interesting thing is that with animals, this is less about sort of personality level optimism or pessimism like we seem to have. But again, that's a little bit up for contention whether we really are sort of born optimists or born pessimists. Again, it's probably it's definitely an interaction, but it's a lot about a product of our environment. You know, what have we been conditioned to expect? But with animals, it has become one of the only valid tests of animal welfare, and especially judgment bias. So there's a few different types which I'll explain, but judgment bias is the optimistic or pessimistic evaluation of ambiguous cues. So for example, with a glass, the ambiguous cue is the half-filled glass, and it's whether you say it's half full or half empty. And usually with these animal studies, you can test a specific welfare context and against the bias and find out whether what the animals basically think of the situation. And I'll explain it better here. Yeah, with the rats, it's that for example, they've tested rats, same rats, put them in unpredictable or barren enclosures, and they'll make more pessimistic judgments, and move them over to enriched housing, and they'll make more optimistic judgments. And you can see here on the table with, for example, macaques, they do a stressful veterinary inspection, they'll judge more pessimistically. Starlings, if you enrich them, they're more optimistic. Dogs, the ones with separation-related behavior, are more pessimistic, and pigs also with enrichment more optimistic. And really, there are hundreds of examples of these studies. And I'm not saying every single one comes out in this direction. There's probably, I think, I don't know, I think off the top of my head, maybe 5% of them don't show any results or come out the wrong way. But the authors often discuss, you know, there's probably a methodological problem, or, you know, they had this or that. But really, this test is such a great way to find out whether welfare is really being improved or decreased. So this is the big question, is how do you test it? So I'm using the dog example here from Berman et al. So if you imagine you have a dog in a room, and the first step is you have to condition it to two cues. So one here, this will be a spatial judgment bias test. So here you'll always put a bowl of food on the left side of the room, or you put an empty bowl on the right, so either or. And you do this again and again. And as you can imagine, if you work with animals, that dog is going to rush to the left side whenever it's there, because it knows it's going to be full. And if it sees the bowl that's on the right side, it knows it's going to be empty after you've done this a few times, so it's going to go much slower. And once you see that difference in speed, which is the sort of criteria for moving on to the next step, you then see what its response is to ambiguous cues. And in this case, that would be a bowl right in the position in the middle, where it doesn't know if it's going to be full or empty. And so you measure its speed. Does it rush towards it, hoping it's going to, you know, get a bowl full of food, or does it go much slower, assuming the worst basically, and assuming it's going to be empty? And so all of those tests that I was describing on the page before are all some kind of iteration of this test, and I'll definitely explain a few later. But yeah, for judgment bias, you can have the spatial location test, but you can also have lots of different cues. You could have visual cues, and I think I've got a few examples here. Yeah, so that's the spatial location one. Visual cues. So this would just be one placard, for example, shown in front of an animal. It doesn't have to change position, but it changes what's on the placard. So with this one and the mouse, you could reward it, give the animal a really good reward if it sees the placard with the 3 stripes. Don't give it a reward, or in rats, you know, often they use punishment if it's the 1 stripe, and then show it the 2 stripe, you know, the middle placard, and see how it responds. Does it expect a reward, or does it, in this case with punishment, does it try and avoid a punishment? Acoustic cues, you can also, I think this is a tactile one, sorry. They've used that with different, for example, roughnesses of sandpaper. They use that with rats, and that worked well. Acoustic cues is a really good one, obviously, because you can really set the grades of the different cues. So again, for a low tone, for example, you could condition an animal that it's always going to get a great reward, and for a high tone, it's not. And you play a tone in the middle, and you see how it reacts. Is it expecting a reward or not a reward? and even smell, which is a really interesting one. So this one they did with bees, and they also found, they also found an effect of bees can have cognitive bias, optimistic or pessimistic biases. I mean, sadly here, the negative context for it was shaking the bee a lot, and they found that the shaken bees ended up with negative or pessimistic biases. So I think that's quite easy to understand why they were negative, the poor things. But they used smell here, where they took two smells, one was the positive, one was the negative, and mixed them together to get the ambiguous ones. And taste as well. You can do that, for example, with rats and sucrose. And the conditioning of it. So as I've been mentioning a little bit, you can have those two extreme cues can either be, for example, positive and neutral, or positive and less positive, or mostly with what we see in lab studies is positive and negative, or punishment. And what we thought, or what the researchers thought originally, that you had to have positive and negative, this really big difference between cues. You actually can just have positive and less positive. Animals are clever enough to know the difference between the two. So there's no need to, to do this test. You don't have to go and punish or electrocute animals as they did originally with the rats. And just a word on the other types of bias. So you've got attention bias. And that's when your emotional state impacts your attention. And yeah, the findings here are, there's a few less studies on attention bias in animals, but still we're finding that animals, like humans, pay more attention to negative cues when in poor welfare. And the example here is rhesus macaques, who, after having a negative, stressful vet exam, those ones paid more attention to the angry macaque faces. And also memory bias. That's when emotional state will impact your memory. This is when animals will remember negative events more readily when in poor welfare. And this was a rat study, for example, where they remembered to avoid arms of the maze where something negative had happened to them. So cognitive bias in dolphins. So at this point where I was looking into all this at first, back in 2016, I think, it hadn't been applied yet to any marine mammals or even any zoo house animals. It had been looked at in a few sort of exotic species, like monkeys in labs, and shown really interesting results. Obviously, dolphins are highly trainable, so they'd be really well suited to this type of testing. And as always, on dolphin welfare, there was a lot of interest, but very little evidence, so it seemed to fit perfectly. And our question was, are dolphin cognitive biases linked to certain behaviors? So we didn't actually put them in or change the conditions of their environment, like add enrichment or not, or transport them or not. We just wanted to look at their different behaviors, and especially their social behaviors. So does their social situation impact their cognitive bias? And this was at Parc Asterix in France, where we had 8 bottlenose dolphins. We adapted basically the judgment bias task that I showed you, the same one as with the dogs. We used positive reinforcement only, so just a positive and a less positive reward. Interestingly, we tested it in social groups. At the time at the facility, the animals weren't really used to being separated that much, and so if we'd have separated them, it would have induced maybe even a pessimistic cognitive bias. So we had to keep them in social groups, but actually it worked super well. And we maybe a few times had to stop test if one of the other, this was during training sessions, stop test if another dolphin came and interfered, but otherwise, it worked perfectly. So I think it could do with other animals as well. So yeah, the measure of bias, similar to the dog study, it was the time taken to return from those middle or ambiguous cues. The cue was the target position. So for one trial, we had the dolphin touching the target 12 times, and we did one trial per dolphin per day. So this is what it looks like, and it's again very similar to the dog study, but we had, for example, on the left, if the target was on the left side of the pool, the dolphin touched it and got a herring. If it was on the right, the dolphin still went to go touch it and came back and just got applause and eye contact, but no fish. So something that they've been conditioned that is positive, you know, they know they haven't, it's not a punisher for them, but it's not as positive as a herring. And once we saw the difference in speed between returning to those two cues, we then put the cue in the middle and try to see which dolphins would be optimistic and pessimistic. And that's what it looks like in real life. So for those of you that train animals, you can see what a simple behavior that is. It's just touching a target and coming back. And as you see, the other dolphins are even in there. And that was actually one of the reasons why we didn't use acoustic cues. If we were going to be testing with all those other animals in there, we didn't want to have acoustic cues underwater that all the other dolphins could be hearing at the same time, and then they would have to do their test later and might be influenced by what they heard before. So that's sort of, yeah, again, something I'll talk about in the second part of the talk, is how you adapt and choose what you test on your zoo animals. So what do we find after all these results? And indeed, we found these two really interesting results one with social behavior. So we found that the most optimistic dolphins in the group were those that showed more synchronous swimming. So synchronous swimming, for those of you that don't know dolphins, is just when they swim together. In this context, we're looking at slow, close synchronous swimming, so a relaxed sort of social bonding behavior. And we found that, interestingly, that the level of synchronous swimming, so if a dolphin had been synchronous swimming a lot, even 2 months before the bias test, we looked at this past behavior data, it would still predict that they were going to be optimistic in that cognitive bias test. But then more than 2 months before, there was no correlation. And that showed us that this isn't a personality level thing. If it was, we looked at behavior from up to a year before, we'd have found that, okay, there's always some dolphins that are synchronous, high synchronous swimmers, and those are the ones that are optimistic. But actually we found that this had sort of popped up 2 months before and was correlated. And this fits in with what we know about dolphins, really, and it's not rocket science either, that affiliative behavior leads to better welfare, but it's actually something that's super hard to prove, even in humans, you know, that having more friends or better friends makes you happy. But yeah, it was really interesting to find that this sort of almost semi-temporary state, where we thought that we discussed that the dolphin's social structure, which maybe changes every 2 to 3 to 4 months, that was what was playing in here. So maybe more than 2 months before, there had been a different social structure and different dolphins had been swimming at different frequencies of synchronous swimming. So it's really interesting. And then the second result we found was anticipatory behavior. And here I want to show a video of what that is. So here you have, on the left side of the pool is where the sessions always start from. You saw that dolphin just popping up its head and having a look. This was about 10 minutes before a session. And it, again, for those of you that work with animals, you'll probably notice or understand that and see it in your animals as well. It can be, you know, animals waiting at a gate that they always get fed from, or looking at a certain place, or listening for sound cues. And interestingly, we found that more pessimistic dolphins showed more anticipatory behavior. And this might be counterintuitive at first glance, but actually this anticipatory behavior is a whole new area, again, of welfare science, where people are finding out from, again, started with lab studies, but moving on to zoo animals and other animals, that if you're in a really poor environment where you have few rewards, that actually those few rewards that you do have are going to be really, really much more valuable to you or the animal. And so they're going to anticipate them. If you can predict them, they're going to anticipate them much more. And there's a really good model and a really good paper by Waters from 2014 where they look at, and they show this really well. So if you look at the dark line, and along the bottom you have welfare going from positive to negative. So you can see that there is some level of anticipation that's good. Of course, it shows that it's looking forward to the event, that it's excited about it. But as you go towards negative welfare, it increases its anticipatory behavior till it reaches a peak of basically, you know, excessive anticipatory behavior, where all it's doing all day is just waiting around for this one thing to happen. And then they hypothesize here that if you go into chronic stress, where it's been in poor welfare for a long time, that actually it will become apathetic and not show any anticipatory behavior at all. So interestingly, and I hope maybe this will be the topic of my next talk, I don't know, but I think anticipatory behavior is actually another one of these whole animal measures, which, even simpler than cognitive bias to measure. It's got much less studied at the moment, but I'm a big believer that it's going to, just by measuring the amount that they anticipate these predictable rewards, I think this could be super useful for welfare studies. And yeah, as I said, some anticipation is good. I'm not saying that they shouldn't be waiting for their food at all. We all do that, even if they're, waiting for the clock to hit whatever lunchtime. But definitely excessive levels are bad. So a lot of talking about a lot of theory, and I hope it's made sense. But a summary of what we've gone over is that welfare assessments can and are being applied at the zoo at different types of levels. You've got these individual assessments that are using many measures and are the most accurate, but they definitely are time intensive. And if you've got these recently developed whole animal measures such as cognitive bias, which can also give accurate welfare conclusions. More optimistic animals are those in better welfare and vice versa. It's a great test of animal welfare. And for me, I've seen firsthand how useful these tests can be. Identifying synchronous swimming and anticipatory behavior as a welfare indicator for dolphins was invaluable, and that was facilitated by that test. And actually, it was also the first study to link anticipatory behavior and cognitive bias at all. So we're learning stuff that we can apply to all other animals too. But at this point, I definitely want to see if there's any questions before we go on to how to apply the cognitive bias test. So definitely, any questions on maybe the theory of it, if you don't understand anything I've said, or anything on welfare assessments.
Hi, sorry, I was just on mute still. Yes, so we do have an excellent question that's come through from Meg. Meg, would you like to pose your question now to Isabella?
Yeah, hi, Isabella, Mike here. So for the part about anticipation behavior, which, well, I'm personally very interested in, how do you determine what too much anticipation is, which would signal reduced welfare, and then Marianne added to that, or when it is in fact too little anticipation, which would also demonstrate chronic stress. So how do you know when you're in the sweet spot?
Yeah, exactly. That's $1 million question. I think I sort of showed that graph to whet everyone's appetites, and actually that paper does as well. But the problem is that we don't have that information yet. They've done that on rats, for example. So if you wanted to know what the sweet spot was for rats, you could find out. But for other animals, we have to just do studies to basically loads of different studies to find in different conditions to find out what that level is. So for example, with dolphins, we've got now, I think, sort of 4 or 5, a couple done by me, a couple done by other people, of anticipatory behavior in different contexts. So we've got a level of anticipatory behavior when there's nothing going on. There's not even a session, a training or feeding session coming up. So actually that's a sort of baseline sort of vigilance behavior. So then we can separate that. When I tested it with cognitive bias, there was an average anticipatory behavior for optimistic dolphins of about 10% of their time, So that was all throughout the day, they were spending 10% of their time waiting for these sessions to come up. And with pessimistic dolphins in that same test, the pessimistic ones were showing about 23 or 24% of their time anticipating sessions. So with dolphins, we've got a kind of a scale, but really only a couple of studies on it. So we basically need to keep doing the research, and hopefully at one point it'll be the same as cognitive bias, where you've got hundreds of studies proving that this is is what it looks like. But yeah, sorry to not give a better answer. I think it's something that you can look at. I think your own animals, if you've got, you know, some in your collection, you can start tracking how it changes over the day, how it changes, for example, I don't know if there's construction noise going on nearby, or if I don't know if you can see other indicators of poor or positive welfare. You can start looking, but it's, in my head at least, and when I use it with the dolphins, I've got kind of an idea of the frequencies, but still thinking in quite general terms.
Okay, thank you so much.
Okay, perfect, thanks. So I do have another question come through from Lizette. So Lizette, would you mind turning on your microphone and asking that to Isabella now?
Yeah, thank you very much. Yeah, so also looking at the practicality of doing these cognitive bias tests, and it's a lot of, well, time consuming, but would you say that the information that you gain from these cognitive bias tests could be used to identify potential welfare, or like welfare indicators or behavioral welfare indicators in the species, and then use them in future welfare assessments? So you would only need to sort of gather the information and then know, okay, so clearly this behavior is linked to welfare, and then we can use that in an assessment, for example.
Yeah, exactly. I think that's, yeah, exactly what I was saying also with the dolphins, and using now, which I do, synchronous swimming and anticipatory behavior as an indicator in welfare assessments. I think the other exciting part, and that I'll discuss a little bit more in the next part, is that I think you can use cognitive bias tests, and maybe, and no, there's definitely wouldn't be for example, a zoo inspector coming in to do a welfare assessment, but for institutions themselves or facilities, if you've trained this cognitive bias test, you can keep applying it sort of periodic times. Once that initial sort of time-intensive effort has been put in, you can keep that there as a continual sort of welfare marker. There's actually not so many good, I guess, animal use industries that have done this so far. People are looking at it with rats, where they're trying to see if lab rats can always be trained to a certain judgment bias task, and you go in, for example, every 3 or 4 months and ask them ask them to show the response to the task and get a measure of welfare. And there's a bit more research that we need to do on the different effects of repeating the same test over time. But yeah, so I think there's 2 ways. Like you say, you can find other indicators from it, but it also can be used as basically a welfare assessment itself.
Yeah, but I can imagine that for some species, it's more difficult to actually apply the cognitive bias tests, just due to practicality. I mean, I think every animal can be trained, but more in that sense. So maybe use information from, I don't know, like lab studies, or maybe someone that actually looks into that, and then we can use that for other locations, zoos, and etc.
Yeah, definitely. Yeah.
Right, thanks. It's very interesting.
Perfect. Okay, we've just got one more follow-up question from Micah, and then we'll launch back to the second half of the presentation, but this is a really good one, so I'll hand it back over to you, Micah.
Thank you, Melissa. Yeah, my follow-up question is about stereotypic behavior. Because I was wondering what your outlook was on stereotypic behavior that may be linked to anticipation behavior. Would that then be qualified as ritualized anticipation, or would it be a bad welfare signal because it's stereotypic behavior?
Yeah, that's a really interesting question. And I wish definitely that I had a whole presentation to go into it. Not that even
Me too.
I don't have all the answers, because it's something that yeah, we're still finding out. But I think how I see it is that actually anticipation and stereotypic pacing especially had been kind of smushed together into one category a lot in the past, where it's been classified wrongly or as the other one, or just no distinction has been made. And I think that definitely the anticipation element of it itself can be defined and can be extracted from that stereotypic element of it. And for me, the way to, if you have, for example, a problem like that where you don't know which one it is, I think I could recommend a paper by Mason and Latham from 2004, which is so good at really diving into stereotypical behavior. And they basically classify these 5 different types, which really helped me then disentangle what anticipation was. So you can have a stereotypic behavior that is, you know, frustration related, or as a kind of a mantra behavior where it's sort of rocking back and forth, or whether it's sort of centrally controlled. So whether it's been in the animal so long that it's not even conscious of doing it anymore. And understanding exactly what the stereotypic behavior is, that's what I'd start with. And there's like a various different tests that you can do to see, to help you understand which one it is. Then, excuse me, then I think you can understand whether it's linked to anticipation or not. And for me, I think that the sort of frustration related stereotypies are the ones that are most likely to be linked to anticipation. And only some stereotypies are the ones that you can improve, for example, with enrichment or different types of interventions. And some of them, like the centrally controlled stereotypies that have been there for so long, you're actually not going to be able to, trying to prevent that behavior doesn't increase welfare. It's too ingrained, and it can even decrease welfare. So yeah, it's a really long-winded answer and maybe got a bit too complicated, but I think they've been too much linked together in the past. I think, first of all, to see whether, for example, an anticipatory pacing is really completely invariant, or whether it looks like it is, but it's actually, you know, still being really vigilant and looking in different places. So defining those first, and then I guess looking at what the different things can be done to improve welfare. But I can send you, if you can get in touch with me afterwards, I've made a sort of decision tree based on that Mason and Latham paper to try and help people understand which stereotypic behavior they might be looking at. So I can definitely send you a copy of that.
Glad. Yeah, I will be glad by that. Thank you.
Okay, those were some great questions, but we'll launch back into the second half of the presentation now, and more discussion at the end.
Brilliant. Okay, so first of all, why conduct these cognitive bias tests? Because even though I'm sort of singing their praises and saying how exciting and interesting they are, they definitely take time, and especially at the start. But what benefits overall can they have? So for the animals themselves, they can be super interesting, stimulating, like learning tasks, part of their training, part of enrichment almost. And I saw that definitely with the dolphins that we were doing it with. It was something really different to the other training that they'd experienced before. And so that was really good. A side note is that in some animal studies, they've even found that the task itself is so interesting and stimulating that it causes itself an optimistic bias. So you almost have to be careful to not make such a fun task that's different to what they know before, because you'll induce the bias itself and affect the test. And the results obviously can help to improve the individual animal's welfare, so that's another benefit for them. And really exciting stuff, like you can even, that we're starting to see that these results from the cognitive bias can determine between anxiety and depression. So really delving deeper into more, I guess, welfare information that we've ever had access to, I think. Can be really useful for staff and managers as well. It reveals these different learning patterns in the animals. So this is an example, this is a graph from the dolphins where each of the different colors are different dolphins. And that's their different reactions to the cues. But knowing that an animal may be, and again, we don't think that they're necessarily personality level optimists or pessimists, but understanding more or less what an animal maybe is predisposed to, or at a certain time, if it's an optimist, it's going to be, for example, taking more risks and assuming better. You know, if you give it an ambiguous cue, it's going to assume that it was something positive as opposed to something negative. And that can help with training. It can also help with different cues that you have in an animal's environment. It can also help staff and managers by giving them objective welfare indicators. And that's what we hear, I guess, a lot with welfare and talking about welfare parameters, but these really are completely objective. This is not someone, I mean, there's always a certain level of subjectivity with, for example, behavior observations. You know, does the person classify it as this or that, or but these are really, really objective, and I guess hard to dispute if you want to publicize the results and look at that. And it can help to manage the animals more effectively. You know, if you understand how the animals are learning and how the animals are feeling, you can, you know, better manage their social groups and the interactions they have with the public, maybe, or with their environment. And yeah, it's also really, really critical for research and education. So the data on these emotional processes of all these different wild animals, which zoos have access to, is just, I think, invaluable, and really adds to the body of research on cognitive bias. I think it's really engaging for the public. There's lots of different ways to explain it and to show it, but bottom line, I think everyone's really interested in the cognition of animals. And yeah, the results can help improve the welfare in other zoos. It can spread further, even the wild as well. I think, like Micah was saying, if you can understand what behaviors are linked to these optimistic or pessimistic biases. So for example, a crude example, I guess, is the dolphins in the synchronous swimming. So we found that if that's true, that more synchronous swimming in this sort of, you know, pair bonded, close, relaxed way is reflective of better welfare. Could we go and apply that to wild dolphins and just look for synchronous swimming and say, okay, well, you know, we see a lot of synchronous swimming in this group that are maybe not affected by, I don't know, anthropogenic noise or plastic or whatever, but we see much less synchronous swimming in this other group. And there you're then translating those results to the wild. Of course, you need definitely more research to make sure you're still measuring, you know, you're still using the same measure, and that it really is valid across a number of dolphin groups. But that's a sort of example of how far it can go. And yeah, after the dolphin tests, there's definitely a few other experiments in the zoo now that have been conducted. Actually, only 3 really. Oh, sorry about that. So you've got primates. This was one study looking at gorillas, chimpanzees, and Japanese macaques. They actually used a slightly different ambiguous Q sort of paradigm, but they found that only macaques showed a sort of pessimistic cognitive bias. Gorillas and black bears, they also used a slightly different paradigm. And they tested the effects of enrichment and visitor density. Neither seemed to impact cognitive bias. And the paper was talking about problems with learning the test. And then killer whales. So this was quite a recent one. They did the same test as we did on the dolphins, the spatial location one. And the killer whales in this case didn't meet the criteria for learning the difference between the positive and the less positive cues. So even though I was saying, you know, that should be enough, sometimes, maybe for some individuals, there wasn't a large enough difference in reinforcement values. So again, they used, I think probably maybe not herring, but maybe salmon or a bigger fish, and they used just human interaction for the less positive. So it could have been for those killer whales that human interaction actually wasn't that much less positive than this big, you know, fish payout, which is really interesting. So looking at these 3 sort of groups of studies, it actually looks quite difficult maybe to apply cognitive bias at the zoo. And I think it's important to remember these are just the first efforts in it. The first 2 also have used a slightly different kind of strand, not to do either with the judgment, attention or memory biases. They use something slightly different. So I think the next slide, I really want to talk about how important it is, I think, to use all these different variables that you've got going on at the zoo to be able to design the test properly. And I don't know exactly what happened in these other studies, but I think it's, as we all know, the zoo environment, there's so much going on and there's so much to think about, and time and effort, that to really properly design a test. There's no reason why it can't be done, but it definitely has to be done really carefully. And a quick note to this book, and I know Melissa sent this around as reading, which is great. If you didn't manage to get it, it's free access on the internet, but this is what I'll be basing these next few slides on, and there's quite a lot of information, so if you need to go back, you can just look at that paper. So these are something called the zoo environment variables, and in this context, I really want to look at what influences the execution of cognitive bias research in the zoo. So why might it be possible or not? Which animals might we test? Which type of test should we use? And what research questions can these tests ask? So research questions, for example, in terms of, is this enclosure better than that enclosure? Or do the animals respond badly to the visitor interactions or not? And the interesting thing, I think, with the zoo environment variables is actually, if you look at them, they can apply to any other type of research being done in the zoo. It's just saying that you really need to consider all these different elements before you design your research. But here we'll look at cognitive bias. So one is a Venn diagram, and one part of it is the animal, the factors to do with the animal, the variables. So different species will be easier or harder to test for cognitive bias. The health of those individual species or individuals, the level of training, life history, personality, the social bonds, the social group management, even the human-animal relationships. You've then got the habitat as well. So is there even space to conduct the research? Can you modify that habitat or install, testing apparatus? How close is it to the public? Can you limit the public from it? And this middle one, does the animal perceive parts of the habitat differently? So do you have an area where it always gets fed from that actually, if you did the testing there, it already has a different sort of, or already biased notion of what it means to be in that area? So then probably it'd be better to do the test in a more neutral area. And the management of the animals, of course. So their daily presentations or public interactions that might interrupt you doing this test. Is keeper involvement in the research supported? Obviously with the training and stuff, that's always, the keepers are integral in this, so it's a big plus or a big positive if the keepers are supported in this. Is there resources for animal training? Ethical approval of some of these protocols, and in-house scientist academic partnerships, and I'll talk about that a lot in the next few slides. And then in the middle of all that, there's animal welfare. So that's affected by basically all of these different things. And that also itself, an individual's animal welfare, will impact whether you should or can do a cognitive bias test on it. And I'll go into these in a bit more detail. So first, starting with the animal factors. And I just want to, as we go through here, this is an attempt to make it a sort of more workshopy and interactive. If you are someone who wants to maybe consider doing cognitive bias studies, or you have your own animals, and it's a fun exercise, try and think about which ones might be optimal for doing these cognitive bias tests as we go through all of these different factors. And then we'll see in the end maybe which kind of test we choose. So I've put some factors down on these columns about what would be optimal for cognitive bias tests, but also that's not to say that if they're not in that species or of that health status that that they can't do them. There just have to be more considerations to be able to do it in a sort of standardized and I guess safe way for the animal as well. So for example, with the species, usually the ones that are optimal for cognitive bias tests have slightly higher cognitive abilities. And actually thinking about that, I shouldn't have even put that in because the bees were able to do cognitive bias. I think what I mean is that the link it has with the ability to train them, which is usually more higher cognitive ability animals are more trained in zoos, but that's absolutely not to say that other animals can't. The consideration also with species is their sensory capabilities. So what type of test you're doing will depend on what their prime senses are, and I'll give an example of that later. Animals in good health are definitely optimal for cognitive bias. You don't necessarily want to be putting an animal with poor health, through this sort of new testing thing, but also you'll probably find kind of confounding results than maybe what you're looking for. Personality, and this depends on the test, and there's not an optimal personality for doing the tests. I'll talk about that more later, and about how personality affects it. There's some studies showing that it has, but also some studies showing that personality in animals doesn't affect cognitive bias. I think the answer is just to know as much as you can about the animal's personality before doing the test. Life history, it's great to know the full life history of the animal before you do the test, so that you don't apply something that actually might have had, the animal, for example, if you're applying enrichment but you don't know that in the past the animal has had a really bad experience or something, knowing the animal better is always good. High level of training really is better. Social bonds and hierarchy, there's not an optimal one really, it depends on the species. Social stress will definitely have an impact. They've also found, for example, with rats, that subordinate animals don't learn as quickly on these tasks, but that can change with their social position. So again, not that straightforward, but something to consider. I think a good human-animal relationship is optimal for the tests, because with training and general, you'll have to spend more time in close proximity to the animal, either if you're training them or even just moving stuff around the enclosure. It's better that they don't, that you have a good relationship with them. And social group management, the best is really if the social groups can be separated without any stress at all, but they can still be tested within the social group. That's not a reason for not doing it. So habitat factors. Is there space to conduct the research? Obviously, it's better if there's enough space. And this is something always to think about, the ability to install the testing apparatus. This doesn't have to be, huge, complicated things. Like as I showed, it can just be a target. But there's lots of really important factors to think about with that. For example, having blind people, not obviously really blind, but people that are holding the target that don't know, for example, what the outcome's going to be. So you have to have, the different communication. Everything has to be quite regulated in terms of what each person, for example, who's holding the target knows about what the outcome of the test is. So it has to be easy for people to, I guess, hold these targets and move around and not disturb, the public or the other animals. Again, better if the test area is away from the public influence, because we don't know, how that might impact the tests. The test can definitely work around public presentations during the day, but would have to be standardized, so not too close before or maybe just after. And again, that's also about knowing about how your animals react to those presentations, and whether, if it's actually just a feeding session where a few people come and watch, as opposed to maybe a once not so regular big show or something where you think they might be more affected. And does the animal perceive parts of the habitat differently? Should be carried out in a neutral part of the habitat. And as I was giving the example before, you have to make sure that it really is neutral, not negative. So some people think, oh, we've got a huge space in this part of the habitat away from the public, let's do it here, but actually the animal never has gone there and finds it really negative and scary. So definitely in that sort of first habituation phase of the testing, it's important to know how that animal is responding to different parts of the habitat. And just some of the management factors. So ethical approval, that's when the zoo will have a process to see whether they want this scientific research to be carried out. And again, there's usually no problems if you're not sort of punishing the animals or doing anything awful, and you'll get ethical approval. And whether keeper involvement is supported, this is really, as I said, really key. And I think probably definitely from my study is part of the reason why they were successful. And you know, it wasn't that we designed this test that was perfect for the dolphins from the first day. We had to go through different iterations and work out which part of the pool to do it in, and how to train and this and that. So, you know, keepers are really integral. Scientific or academic partnerships. So yeah, this is again really key. And this is basically because it does take time to set up and organize in the beginning, and it can be either in-house. So if you have a scientific department, they could probably do it within a zoo, or an external student coming in. And this is also something that is definitely appropriate for definitely master's, PhD, but I'd say even an undergrad student. It just takes a lot of organization, especially if you have an undergrad student with maybe a supervisor at the zoo. That would definitely work. Yeah, and more resources are always better, of course. So training and research skills will definitely help. So yeah, going through that, if you were thinking about whether you've got an optimal animal in your mind, for those of you that are looking to do this with some animals, the other sort of I guess question to ask is, yes, there might be an optimal one to start with, and again, this depends on resources you have and whether you do have a partnership, but welfare need is also that other side of the optimal, you know, practicality versus welfare needs. If you have some animals where actually maybe it's not so practical, you know, they're not as trained, I don't know, the public maybe are always there or something, but you think that they've got reduced welfare, I think that could be a really important reason to choose them for doing cognitive bias tests on. And I'll show you in the next couple of slides how I think you can try and get around some of those things. So yeah, just to say that the welfare is really important. And yeah, that these partnerships with academics are something that could be really mutually beneficial and are great ways to solve welfare problems. I think I've seen that with a good few zoos where actually it's not just about you know, the scientists wanting to get a degree out of it or whatever. It's you can control that conversation as a zoo and say, look, we have this problem, and I think that's coming with more transparency within the zoo industry as well, and more understanding from the outside. You say, you have this problem here, we've got some ideas how to solve it. Could we try cognitive bias or this or that? So I think that's the way to go. So now I just want to kind of to end up with look at a few case studies to demonstrate some of the different, I guess, scenarios which I think will definitely be existent in the zoos maybe some of you work in, and how we might get around that. So the first case comparison is to have a small zoo with, for example, no scientific department or academic calibration, not all the animals are trained, and very few resources for projects, versus a large zoo, the scientific department, good level of training and loads of resources. So obviously, it's being very, I'm generalizing a lot, there's a lot of other factors that are always involved, but if we just look at this, taking a small zoo first, I think, going back maybe one step, but I think in this kind of situation, I'd really recommend somehow getting an academic collaboration. These, even though I'm saying that these tests are, yeah, alternatives to welfare assessment, they definitely require setting up and time in the beginning. So I think that would be really key to making them work. And another one of the alternatives is, for example, if a keeper goes through an academic degree themselves and gets supported by the zoo, that could also work. But I'm just talking about someone who's really full-time working on the project to organize it and to see it through. And I think there's a step-by-step process which you could go through to do that. From the beginning, you could choose a project leader within the zoo, someone who's interested in looking at getting this developed. Highlight, like the process we just went through, highlight some animals and some welfare questions to be investigated. Put together, for example, a one-page document maybe with ideas and potential species that you might test. And at that point, I think try and hand it over or collaborate with universities. And yeah, it doesn't have to be just universities as well, it could be colleges, or you can sometimes also find just students or interns that are really capable and keen to do research like this. But yeah, it definitely needs someone in charge of it for this training. And then you can also work on the training while that's sort of all getting set up, work on the basic training for the animals. So for example, gating them into separate enclosures. Not necessarily, you don't have to separate them, but at least being able to move all animals from one enclosure to the other. You could train them from going from one place A to B, one target to the other, and targeting the sort of basics that you could already work on, even just to, if this is even a few years before you're able to do the actual tests, but getting these sort of wheels in motion before doing it. And then going back to the large zoo. So I just want to look quickly here at the advantages of each. This is obviously a much sort of more conducive situation to being able to do the cognitive bias tests. But I wanted to talk a bit about having a in-house scientific department versus a university sort of external collaboration, because they're different advantages of each. So for in-house science departments, I think you have the advantage of definitely a closer relationship with the staff and the management, which can really help when organising everyone, obviously. Usually better knowledge of the actual animals, and they're on site, so it's actually practically easier to carry out the test and to, I don't know, do retests if needed and all of that. But there's definitely advantages to the other side as well. They usually, university collaborations, they usually have a student that can really dedicate all their time to the project. They're generally, and this is not a specific example at all, but they generally have more scientific expertise from not just from them, but from maybe their supervisors at the institution and all of that, and resources. And they can be more objective sometimes. So yes, it's great to know the animals, but sometimes that can even bias you in how you're designing the tests and interpreting maybe the results. So there's definitely advantages to each. I think for me, this one is really one of the most important, but can be applied also. I didn't put it in the advantages of the other one, but it depends how big the scientific department is, and if you have a student coming in that, or someone that is able to dedicate all their time to the project, that's ideal. So just a quick note on the testing process.
Quick note that we're running a little bit over time at this point, so don't know how many slides you've got left, but just so you know.
Yeah, only a couple really. So just a quick note on the testing process and why I keep saying that someone needs to be kind of in charge of it the whole time. You've got the first bit on habituation and training. So like I was saying, you've got to get the animal used to the test area, the objects that are used in the test, and the people. You then condition it to the cues, whereas like with the dolphins, you teach it that one cue is going to give it a herring, one cue is going to give it something less positive, and then you test the actual ambiguous cues. But to pass, for example, from step 2 to step 3, like with the dolphins, there has to be a way to know that they are in fact conditioned to the cues, not just that you say, oh, it knows it, let's move on. So for us with the dolphins, they had to consistently return from the positive cue 2 seconds faster than the less positive cue. So we have to see them coming back really consistently a lot quicker than from the other one. And so this, obviously, the person who's running the project has to always have this, in their mind, and organize and check which dolphin's ready to pass on to which step. Like I was saying, those giving the cues and the rewards should be blind. So this is not knowing if they're going to get which reward they're going to get from which, for cue, for example, so that the clever hands effect doesn't play out, where the dolphin or the animal can pick up signals from the human about whether it's going to get a reward or not. You have a pseudo-random order of trials, which just means that it's predetermined so that you don't have, for example, accidentally all positive trials and only one less positive, because that might bias the animal itself. And yeah, everything has to be recorded carefully, usually with video, so that you can do careful analysis afterwards. So this is a quick overview of why it does take a lot of time. And so, yeah, an example with the dolphins, when we did those, so this was with, for example, only 5 animals. If you were doing the trials, I would imagine it would take about 15 hours of work to put in all the data as well afterwards per week. So just a second case comparison before we end. I want to look at that welfare need versus practicality kind of question. So if you had, for example, on this case study, male polar bears that had low level of training, maybe lots of stereotypic pacing, reduced health and few resources, versus, I don't know, a lemur group who had high level of training, no welfare problems, lots of resources available, and they're about to be moved to a new enclosure. So what kind of cognitive bias tests could we set up for these? So for the polar bears, I think you could still do a judgment bias test, even though there's a low level of training. I think with these guys, for example, you could do 5 different sound cues. So have, like I was saying, a high note. If the polar bears would have to come over to a certain area. If they heard a high note that was played, for example, they would get a great reward, a tasty reward. And if a low note was played, they would get something less positive, maybe a much smaller reward. So all you need for that is for them to be staying at the reward bucket basically and listening. And so that's something that's kind of easy. And yeah, we could use fish for maybe the cues. The measure of bias would literally just be how long does it take to approach that food bucket. So we'd expect that when the less positive sound was played, that it would take longer because it knows it's not going to get a reward. And for example, there could be some really interesting research questions here because this animal might have more welfare, does seem to have more welfare needs. So you could look at whether stereotypy is linked to the cognitive bias. Really quick note on choosing cues. So why, for example, wasn't smell suggested for the polar bears who have a really good sense of smell? So these cues must be on a continuous gradient where the value between the cues are very similar in distance. So with spatial acoustic, that's really easy to make it even. But with smell, for example, you have 2 different odors and you're maybe mixing them in equal parts, but you don't actually know whether maybe the different smells already have different, meanings or connotations for the animal that is actually harder to see than just a frequency. And again, this could be with frequency. Maybe if you played this to dolphins, I don't know, a lower frequency would mean something different naturally or inherently to them. So it takes a lot to think about which cues might be used. Yeah, and that's what it's harder to sort of test in a zoo setting. Quick note, and I'm not going to spend long on this, but just there is a few studies that are looking at cues that don't even need to be conditioned at all. So they did a test on, I think it was hens, where they had a picture of a chick for the positive cue, which morphed kind of into an owl, i.e. a predator, for the negative cue. And that worked for their test. So also it's worth keeping in mind whether maybe there's some cues, for example, sounds maybe that you could use that are inherently positive and negative for the animals. And the last bit, looking at these animals that maybe might be easier to test. So you could keep them in the same group while they were being tested. You could use visual cues with lemurs, definitely. Yeah, these guys would be better trained, so training wouldn't be a problem. And you could easily go through and ask, for example, are they more optimistic in this newer, more enriched enclosure that they were being moved to? So no problems there. Last slide on how to get started after all of this. I think about your zoo environment and variables in the situation you're working in. Definitely collaborate with scientists. It's up to them. They can look at the gaps in the literature. They can research the types of tests. They can also learn, ask other people, learn from others' experience. And then together, this zoo sort of academic team, I think you can choose the criteria and the cues together, plan the training, and establish the testing schedule and get going. But yeah, I think the key is having this team in place. And final conclusions. So yeah, these tests are definitely a way to measure overall welfare without doing this full welfare assessment. They can clearly reveal welfare state and their objective. These environment variables, which are going to be different in every single zoo and for different animals, will dictate the test design, and I think really have to be considered to make it successful. And these collaborations with scientists or someone with a science background who's going to spend their time developing the tests are key, really, to getting it started. But I fully believe that once that's in place and the training is done, that these tests can be repeatable and long-term welfare assessments, as well as obviously identifying other welfare parameters linked with them. Yeah, and I just preempted my last point. So thank you very much. Sorry I took a bit longer. I'd like to thank definitely my supervisors for my PhD on the cognitive bias work. Thank you to EAZA really so much, and Apenheul for their work going to prepare for the conference. And yeah, definitely get in contact and ask questions.
Okay, perfect. So that was some really excellent stuff and given us a lot to think about. We do have a few people that have got some brilliant questions that I'll call in a moment. If other people do have things to get to and other time commitments, this will still be recorded so you can catch up on it later, but it's just such good content and we want to keep diving in. So firstly, I might hand over to Marianne if you're there. Would you like to ask your question directly to Isabella?
Yeah, thank you, and thanks, Isabella. I just wondered, you mentioned there that knowing about the life history is important. And I wondered if you'd looked into the history of the dolphins that were shown up as pessimistic, because I kind of remember reading that pessimism could be affected by poor welfare in early development stages. So then I was kind of wondering if that had effect and whether pessimism could actually change if welfare was improved.
Yeah, I think that's a really good question. We didn't look, in terms of life history, we knew, for example, where those dolphins either had been born or some of them were old enough that they'd been still captured from the wild. We knew where they'd spent their sort of time and how they'd, I guess, been managed over the years. But I think your question about, yeah, whether you can change first of all, your point about early development and maybe forming I guess a sort of lifelong pessimism is definitely valid, and I'm sure it's true for a lot of animals. I think the interesting thing with the dolphins, and like I said, that we found that that social behavior had changed already 2 or more than 2 months before the test, and that was what seemed to be correlated with the cognitive bias. Although we didn't test the cognitive bias again, if it was up to me, I think predict that the dolphins' cognitive biases would also change, maybe not completely, but a little, but you know, maybe some of them would have flipped between optimistic and pessimistic every time that social hierarchy got muddled up and one of them that was on the top was now on the bottom, or reproductive status changed. So I think from what I saw with those dolphins, that would be a reason why. But you raise the great question that we have to test these again and again to really understand, you know, maybe it's true, maybe some of those dolphins are always pessimistic, and then we should go back and find out why. But at the moment I don't have that information for those dolphins.
Yeah, brilliant, thank you.
Okay, so we'll hand over now to Kat. Kat had an excellent point earlier. So Kat, are you happy to turn on your mic now?
Yeah, thanks for that. And that was really fantastic, Isabella. My question kind of follows on a little bit from Marianne's, in the sense that you were discussing on this idea that it's quite a temporary state, it's more behavioural than personality. And you've set up optimism, pessimism as a test, but do you think there's scope to potentially in the future to use it actually as a tool for inducing more optimistic states? And then following on from that, is there is that perhaps being, you know, playing with fire? Because then there's also that risk of stuff that Mason and Latham talk about in 2010 about, is it better to have enriched and lost and never enrich at all? And I guess with that optimism tendency, is it kind of problematic potentially to introduce that situation and then withdraw it as well?
Oh, great questions. I guess a couple of studies pop up when thinking about that. One of them was really interestingly on donkeys that had been rescued from really poor welfare situations and had then been put in a sanctuary in presumably better welfare conditions. And they were much more optimistic than donkeys that had lived in the sanctuary, the positive welfare sanctuary, their whole life. So probably, like you were saying, that, or a little bit, that the pessimism before has made the optimism more, even more positive, and at least for that period they were more optimistic than the other donkeys. So in that way you could use it almost as a tool. I mean, not that you'd want to put anything in a poor welfare situation, but just to be aware that it can change. It's not so much that you know, that we shouldn't try and change an animal's level of cognitive bias. The other thing, and I just read it very recently, a few days ago, is that there was a study with ravens looking at emotional contagion and cognitive bias. And they found that two ravens, they put one raven doing this cognitive bias test and one raven just next to it in a separate cage, but watching. And they found that just by observing the welfare situation that had happened to this other raven, the observer raven also changed its cognitive bias. And there they found that actually it was only on the pessimistic side. So only if something bad done to that raven would this raven choose more pessimistically, not optimistically. So if something good was done, they wouldn't choose more optimistically. But that's the first study I've seen looking at that, and I think it's something that we could definitely needs to be investigated further, because it could, you know, I don't think there's a reason why it shouldn't work on the positive side to some capacity. But yes, I think we should definitely use it as a tool to also looking at those different behaviors. For example, the synchronous, going back to dolphins, synchronous swimming. If we know that maybe synchronous swimming with each partners can induce positive biases, maybe, you know, because we think that might be a proxy for pair bonding, we maybe then need to look at those pessimistic dolphins, try and make them pair bonded with other animals more closely, and that hopefully will induce the optimistic biases. But yeah, really great question, and I agree.
Perfect. Are you happy to move on, Kat? I think
Yeah, that's wonderful. Thank you.
Perfect. So I had another question come through from Anissa. So Anissa, would you like to turn on your mic now?
Yes. Could you hear me?
Yes, perfectly.
Okay. Thank you for the opportunity. So I would like to ask you about how to do the test, especially for the animal in rescue center, because for the animal in rescue center, in where I work, most of the animal we projected them for being released to the wild again. And in the rescue center where I work, we have never tried to train any animals to follow any command, since we are a little bit afraid that it would influence their behavior later when we release them into the wild. So do you have any suggestion on this case? Thank you.
Yeah, of course. Great question as well. I'm sorry I couldn't spend more time on it in the presentation, but I think you can definitely do things. It might be slightly harder logistically to set it up, but if you've got the resources and the willpower to set up a way of, for example, remotely delivering food into the cage or the enclosure, that would hopefully be one solution of using having a reward and maybe a less positive reward. You could just have two different sizes. I don't know. For example, say we're talking about, I don't know, lions, big chunk of meat and a small chunk of meat that are delivered, for example, remotely. And again, you could use something like sound cues or visual cues that don't involve, you know, touching a target or being trained. You can just place the cue on the outside of the cage, or play the sound, so you don't have to get near it at all. And you could definitely, you know, it would take work. Obviously, I think the remote sensor for dropping food might be the hardest bit, but it can definitely be done
Yes.
if you're really keen to do it. So that would be sort of my first suggestions.
Okay, thank you very much for the suggestion.
Perfect. Okay, so we might head to our last question now. So Freysha, would you mind turning on your mic and asking your question?
Yep, hello. Hi, Isabella. Thank you for your
Hi.
presentation. I just had a quick question about group house species, which maybe have dominance hierarchies, and whether dominant animals could influence, you know, what's seen or the participation of subordinate individuals, and whether you'd had any experience with that.
Yeah, great question. I think they definitely can. I think that again will depend a lot on the variables that you have in that certain setting. So if, for example, yes, there's a strong dominance hierarchy, but there's a really high level of training where you can really quite easily separate the animals, they usually will stay in certain different areas of the enclosure, and you could then conduct the test. I think you could go ahead with it without you know, worrying too much about that. Again, like I was saying with maybe the acoustic cues in the dolphins, it would be better to have some kind of a cue which is really only accessible for that animal right in front, that doesn't like disseminate to the rest of the, or is visible maybe to the rest of the enclosure. But otherwise, for example, if you can't really separate them, I think that yes, it definitely could have an effect. And you know, sometimes you have to just work with what you've got. And for example, maybe if only the dominant animals are allowing themselves to come forward and nobody else is, try and just test the dominant animals and you know, test them with some you know, obviously take that into account, but look at, if you've got enough of a sample with just dominant animals, look at them and the rest of them, maybe other behaviors that they show, or other, you can apply enrichment and see. But yeah, I would always suggest carefully, for example, keeping track of which one, if it changes a lot, for example, which is the dominant subordinate, and if that's changed at all during testing, because it definitely can have an effect. And there's loads of different papers looking at that, so I definitely recommend reading them.
Okay, thank you.
Perfect, excellent. Okay, well, I'll hand it back to you and Isabella in a moment for the last word, but I just do want to say that this presentation will be recorded and I will send around the link, and all the papers and things that we've been mentioning as well. Don't worry, we'll source them out, send across the links for those, and if they're non-access, we'll send a link regardless, and you can decide if you want to access those papers. But so firstly, on behalf of us and myself, thank you so much, Isabella, for this presentation. It was absolutely phenomenal. I've learned so much, and I'm sure everyone here has also learned something from today. Some excellent participation in the comments and questions, so thank you everyone for that as well. Just letting you know that the next webinar will be hosted next Wednesday, and when I send around the email, I'll send around the registration link for that. It will be with Frances Cabana, so a welfare nutritional specialist from Singapore. So that is going to be very good as well. But just want to hand back to Isabella for any last comments before we wrap this up.
No, not at all. Thanks very much again. And again, really great questions, super stimulating. So love to keep it going. Let's continue on Facebook or wherever else.
Exactly. And if anyone does want to email Isabella or email me, and I can filter through some questions to you, we will be posting this on Facebook too, so I'll be monitoring the comments for that if anyone has any further discussions they want to chat about in there. So the conversation's not over, and cognitive bias testing is something that's so interesting, and so at the forefront of welfare science, I think, moving forward. So it's really interesting stuff. But yeah, so I think that's all we've got time for today. Sorry we went a little bit over, guys, but I think it was well used time because it was just really interesting altogether. So I'll be in touch with some more information, and hopefully you can join us as well for the webinar next week.